Hi, in today's video we are going to see how we can generate synthetic image datasets using a Gaussian splat based rendered 3D environment. So let's get started. So as soon as you come to our platform, you can use the generate data button to start generating the environment. As you can see, we have various environment integrated within our platform: warehouse, retail stores, Terrace, and different GPT based warehouse as well. So we can select one of our existing project. So we have created a 3D Gaussian splat representation of our Terrace of the office. So we'll be just using that to create a synthetic dataset. So we first have to enter some dataset name. Let's call it Terrace DS2 and click on the proceed button. As soon as you do that, the whole Gaussian splat based 3D environment would be rendered into your web browser, which you can then edit. You can add objects, change the lighting condition, and do multiple other things to generate synthetic data set using that. So as you can see, we have loaded up the environment. So this is the 3DGS based representation of our office Terrace space, which we have created. So how did we create that? We just recorded a video of our Terrace. We uploaded to our platform. We reconstructed the 3DGS based Gaussian splat 3D environment, and then we have integrated within our platform to make the users edit it and use it to generate synthetic image datasets. So there are a couple of things which we can do with this 3D environment. So let's start with changing the lighting conditions. So here we see we have different lighting configuration using we have hue, saturation, temperature, intensity. We can configure the lighting parameters to adjust the lighting condition. If we want some greenish light or within some saturation range, we can do that. We can also use the randomize lighting button to see the variations which are within the intensities that we have specified here. So I'll just keep it normal and move back to the original lighting condition, so making having the maximum intensity. So okay, so this is the original lighting conditions which we have. Then we have the camera tab as well, which we can use to spawn a virtual camera within the 3D environment. So first is the image resolution. So let's say if you want to generate 1920 and 1080 resolution based image, we can specify the resolution. We can change the field of view. It could be 100, 120 or 90 or anything which you wish to specify here. And after that we can see the camera position, which you can modify. So if I give X coordinates, Y coordinates, we can easily modify these parameters to quickly set the camera view, or otherwise we can use our mouse controls as well to change the camera view, and we can modify the height. Let's make it 300. After that, let's say we want to modify the roll pitch yaw. If we want to orient the camera in downwards direction, we can just reduce the pitch value. We can also change the roll yaw value to move the camera on the left and right axis. Let's reduce the height to 200. Okay, so once you are satisfied with the camera position, then we have the ability to add new objects to the scene. So we can specify a cube within the environment. We can change the dimensions. We can change the height of this cube. So let's make it little bigger, 300. In Y direction, it's 376. Okay, and we can use this change location button as well to modify the cube location. So I'll give it a height of 30, let's say. And now let's try to spawn the object within this cube. So let's say we want to spawn a ladder within the scene. We have a list of different objects that we can spawn, but in this case, let's try to spawn a ladder. So within this cube, you can see we can use the randomize button to change the orientation and the location of the how ladder is placed. We can place multiple objects as well, just increasing the count. But let's say we are satisfied with the object which is now spawned. We can go to the other location as well to spawn more objects. So let's say I want to add one more object. So I'll just go there and spawn this cube. I'll maybe change the height to, let's say, 30, and let's try to spawn something new. Let's try to spawn a chair within the environment. So we'll just select this chair icon, and let's give this min and max count. We can have multiple chairs as well. So yeah. So let's say in this case, I just want one single chair. So I can again use this randomize button to place it anywhere I want in a randomized way. And this is how we can generate multiple objects within the scene, and how we are doing it internally. So we are using segmentation of the whole scene that we have done on top of 3D Gaussian splat to understand how the scene look like, and then identify the surface and boundaries of all the objects which is there in the scene, and on top of it, so that we can easily spawn these objects. After that comes the annotation part. We can select different annotation format. One is YOLO with bounding box information. Other is COCO with bounding box, semantic segmentation, instant segmentation, depth, and normal. So we can select any of those according to our requirements. And once we are satisfied with all the configuration, we just need to hit the generate data button. We can specify how many number of images we want to generate. So let's say we want to generate 1000 images. We can enable the path tracing button to have more realistic looking images, but it would take more time on the rendering side. So let's say in this case, we are going to specify 64 samples per pixel and just hit the generate data button. Request goes to our backend, the request gets submitted, and once the data set is generated, you get an email which you can just download, and you can train your computer vision models with better accuracies on the environment which you have just created using a video of your environment. So that is it about the platform demo. Thanks for watching.